Welcome back to the deep dive. Okay, today we're not just scratching the surface. We're really jumping into something fundamental, truly fascinating in aviation, the principles of aerofoils.
Absolutely. It's that invisible magic, isn't it? The thing that
Yeah.
actually makes flight possible.
Exactly. And our mission today in this deep dive is basically to equip you, our dedicated learner, with that solid foundational knowledge of how aircraft genuinely defy gravity. This isn't just about, memorizing lists of facts. It's about building a really robust, kind of intuitive understanding that's going to serve you incredibly well, especially as you gear up for those ATPL theory exams.
That's the goal.
We're drawing our insights today mainly from a really excellent source, Subsonic Airflow and Aerofoil Principles. It's exceptionally clear, very detailed, and it really unpacks the how and why behind pretty much every aspect of a wing's performance.
It really does. And what's so fascinating, I think, is how these shapes, they look simple, right?
Yeah.
We almost take them for granted. But they're engineered with such precision to harness these invisible forces of air. I mean, they form the very foundation of sustained flight.
Yeah.
It's absolutely critical knowledge for anyone who wants to fly an aircraft.
It really can't overstate it.
No, because it underpins, well, pretty much every decision a pilot makes regarding speed, configuration, control, the lot. So in this deep dive, we'll try to strip away some of the jargon, break down the complex stuff into understandable bits.
Get to the core.
Yeah, explore the fundamental why behind lift and really dig into how aerofoils behave under different conditions. By the end, hopefully, you'll not only have the answers to those tricky exam questions sort of ready to go.
Fingertips.
At your fingertips, exactly. But you'll also have, hopefully, a deep, practical understanding that's going to be invaluable, throughout your entire flying career.
All right, let's kick things off by looking at the very architecture of flight, aerofoil anatomy. So when we say aerofoil, what exactly are we talking about?
Starting point.
Our source defines it pretty simply. A shape capable of producing lift with relatively high efficiency. Now that sounds straightforward enough.
Deceptively simple.
Right. But here's where it gets really interesting, because that short definition hides a remarkably intricate design. Every single part is absolutely crucial for understanding how it generates that lift, that force we need.
It's like looking inside an engine, isn't it? You need to know what each part does, each gear, each lever, to really grasp how the whole thing works together.
Perfect analogy.
Indeed. And look, for your ATPL exams, knowing these terms, really knowing them inside out, and more importantly, understanding their function, it's just non-negotiable. So let's walk through the key structural bits, just like you'd look at a detailed diagram, say figure 4.1 in the source.
Okay, lay it out for us.
Right. First up, we have the chord line. Now, the definition is a straight line joining the centers of curvature of the leading and trailing edges of an aerofoil.
Okay, centers of curvature, so not just edge to edge.
Exactly. Imagine the very front, the leading edge, has a certain curve, and the trailing edge might too. You find the center of those curves and draw a straight line between them. It's a reference line. It's not necessarily following the bottom surface or the top surface. It's just a straight geometric reference.
Got it, the baseline.
Precisely. It's the fundamental baseline. Almost everything else, critical dimensions, angles, even where we say the forces act, it's all measured relative to this chord line. It's like the central axis for all our analysis.
Makes sense.
Building on that, then, you have the chord itself. This is simpler. The distance between the leading and trailing edges measured along the chord line.
So the line is the reference, the chord is the length.
You've got it. The chord line is the reference. The chord is the actual measurement of the aerofoil's length along that specific line. And it's a vital dimension because lots of other characteristics, things like camber and thickness, are often talked about as percentages of this chord length. So a longer chord usually means, a bigger wing, more lifting area generally.
Okay. Chord line, chord. What's next?
Next, we have the mean line, or sometimes called the camber line. The definition here is a line joining the leading and trailing edges of an aerofoil, equidistant from the...
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.